calculation of equivalent capacitance. Calculation of equivalent capacitance. So here 2-3 points we have to remember. So first point we can say, when the 2 points, when 2 points are in same potential, then those points can be joined together. Then those points can be joined together or treated as same point, or treated as same point. Second thing, if there is no charge in any of the capacitor, if there is no charge in any of the capacitor, then that capacitor can be removed. Capacitor can be removed from the circuit. These are the 2 points which we have to keep in mind. Then the problem will be a little bit simple. See, first example. Let we are having, these are some different capacitors. A and B points are there. Let all having capacitance C. And question is this: like this. So find the equivalent capacitance of circuit between point A and B. This is the question here. Now, first of all, equivalent between A and B means if we are joining a battery across A and B, so what is the effect of, or which of the capacitor shows the effect on the circuit, that will come in the equivalent capacitance. Now, so if we are connecting for example, a battery here, so what will happen? Charge Q will come here. Now, here charge Q will come, that charge will leave from here. How now here charge distribution may takes place. So first of all, if charge distribution is taking place, see, if I am looking here E and F point, E, F, G point, so what I found here, E and F are at same potential. Why? If I am applying Kirchhoff law between E and F point as well as between F and G point, so how to write? By this path, VE, nothing is there, is equal to VF. E and F are at same potential, and now if let charge distribution is there here at Q1 and Q1, if I am applying Kirchhoff law, the whole loop is also, So we will find Q1 value is equal to 0. The Q1 value is 0, or E and F are same potential as well as F and G also same potential. The same potential points are the common point. According to this, when two points are in same potential, then those points can be joined together or treated as a same point. So here in the exam, in the question here point E, F and G are at same potential, or we can say, or there is no charge between the capacitor, or there is no charge on capacitor which are connected between E, F and G. On capacitors which are connected between E, F and G, those capacitors can be removed. Those capacitors can be removed. Anything we can follow. Then see the diagram. If I am removing those capacitors, so what will come here? A, this is A point. I remove those capacitors. F point, this is G point, then B. See here. Now these two capacitors are in series. So 1 by C equivalent is equal to your 1 by C plus 1 by C. The C equivalent will be your C by 2. Or as I said, these 3 points can be treated as a single point. So let E, F, G treated as a single point. The between A and E, A point here, between A and E, one capacitor. Between E and F means same. F and G also same. The loop, there is no meaning of any capacitor. Then G and B, C, like this. So when they are making just like this type of loop, starting and finish point, there is no meaning of this. So now A and C, B again are at a series. The C equivalent will be your C by 2. Likewise, we can convert either in the form of your removing the capacitor, or we can make a same point, common point like this. Now see another example. Now in this diagram, see, question is that find the potential difference between E and F. This is the question here. Now how to calculate? See, according to Kirchhoff law, if Q charges goes here, that Q charge your difference divide, let here it Q1, then here also your Q1, and here let Q2, here also your Q2. So first equation we can say Q is equal to your Q1 plus Q2. This is your first equation. Second equation, we can apply Kirchhoff law in this loop. See, minus Q2 by C4, minus Q2 by C4, minus Q2 by C3, minus Q2 by C4, minus Q2 by C4, minus Q2 by C3, minus Q2 by C4, minus Q2 by C3, minus Q2 by C4, minus Q2 by C3, 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 min plus E, this is 0, or we can say Q2 1 by C3 plus 1 by C4 is equal to E. This is your second equation. And now see the third equation. From third equation we can make applying Kirchhoff law in the outer loop. See, minus Q1 by C1 minus Q2 by C2 plus E is 0. That gives us Q1 1 by C1 plus 1 by C2 equal to E. Third. So from these two, second and third equation, from second and third equation, we can write Q2 is equal to your E C3 C4 by C3 plus C4, and Q1 is your E C1 C2 by C1 plus C2. Now, if we want potential difference, now question is that potential difference. So, for potential difference between point E and F, we can apply Kirchhoff law here from E to F. So, VE minus Q1 by C2, then plus Q2 by C3, which is equal to your V at F. So, VE minus VF written as 1 by C2 of Q1 minus 1 by C3 of Q2. Now, substitute the value of Q1 and Q2. See. So, VE minus VF is equal to Q1 by C2. So, see from here Q1 by C2, that will give us E C1 by C1 plus C2 minus Q2 by C3. Q2 by C3 is your E C4 by C3 plus C4. Now, little bit simplifying. E we can take common, C1 C3 plus C4 minus C4 C1 plus C2 by C1 plus C2 into C3 plus C4. Now, see the very important point also, VE minus VFC. C1 C4, C1 C4 cancel, C1 C3 will be there, and here C2 C4. So, E C1 C3 minus C2 C4 by C1 plus C2 and C3 plus C4. So, this is the potential between E and F. Now, conclusion, very important point here. If E and F are at same potential, or what is the condition for E and F are at same potential? See, after knowing the potential difference between the E and F point, see, as VE minus VF is given as E C1 C3 minus C2 C4 by C1 plus C2 into C3 plus C4. From this we can conclude. What can we conclude? If C1 C3 is equal to C2 and C4, then point E and F will be at same potential, and this is called your Wheatstone-Bridge condition. This is the condition of balance Wheatstone bridge. Balance Wheatstone bridge. So important result. This is a very, very useful result. Okay, see, if this type of arrangement is there and product of opposite capacitors C1, C3 is equal to C2 and C4, then the E and F point will be at same potential. So once again we can write when C1, C3 are product of opposite resistance capacitors are same. C1, C3 is equal to C2 and C4, then E and F, point E and F, then point E and F will be at same potential and same potential point can be joined together also, and same potential point can be joined together. So then equivalent circuit become, then equivalent circuit can be made like this also, can be made like this. See, this circuit can be made like this also. These are the effective circuit if this is the condition, and E and F are the same point, and this is C1, C2, and this is C3 and C4 like this. So this is the condition for balance Wheatstone bridge also.